I actually I don't have to convince you here. We got into some details about hawkBit, so it's not really a beginner session, but we can make that as a beginner session. So, you know, we will navigate a little bit, but I will get into some details of hawkBit itself. So I actually put intermediate in the session level just because there was already a hawkBit 101. So you attended? Oh, you guys. Oh well, so you are like users right now. We have Dominic, that is the master of hawkBit. All right, so let's get started. Let's do it. So first of all, special thanks, uh, Eclipse Foundation first for all the support that is given to members. Of course, Bosch that sponsored this session. That was not accepted, and then we got accepted. So it was like really exciting. Um, and Dominic and the Hawkbit dev team, so they are like really supporting in the chat. I don't know how you guys can work and answer to all the questions. Like, so really great work. Um, of course, our customers for having adopted Update Factory, and then I will get into a little bit more about what it is, and all the announcements that has been done in the last 2 years, and of course, all the Kynetics team for having trusted, the motivation of doing this work around Hawkbit and the vision that we had of developing something around Hawkbit. So a little bit about me. So I've been working in aerospace. This is how I developed like interest for embedded computing. And I've been working at Kynetics in the United States. And we are members of the Eclipse Foundation, the IoT work group, and the new edge computing work group that has been just founded like 2 weeks ago. I'm passionate about retro computing, actually. I'm restoring in my spare time the Atari 2600 1977. So it's the first revision of the 2600 with the 6 switches, not the 4 switches model, right? It's called heavy duty because it's like really heavy. And, I love to restore these old guys and write some assembly code. Yeah. Okay. So how we got here? Kynetics it's a small company working. We do operating systems for embedded computers. Uh, our customers have different chips, different processors, and we don't deal with systems that are deployed in millions. We have like very specialized and expensive embedded system where we are working on. So we are talking about like thousands, like 3,000s, 5,000s. So I wouldn't say IoT, but it's like still general embedded devices. And um, when we do an OS and we want to test an OS, we test, of course, when we just when we do it, we have hardware and we test that software, the OS, the entire OS in the hardware we have in the labs. But then we want to deploy that thing for testing at the customer location. Initially, we wanted that to be done in a way that we wanted to avoid what we call the first flashing. So first flashing is when you have an image that you download from whatever website, right? And you want to try that thing on your embedded device, like a Raspberry Pi. You go over like some flashing, DD, or if you have like an Android-based operating system, you're using Fastboot. That is another tool for flashing images in partitions around the eMMC or SD card, depending on the case. And that thing was really time consuming. We needed a way for customers to deploy with literally a drag and drop action the image that we have compiled. The pipeline was uploading the image on a delivery server, so an artifact repository, and then with a UI, you can decide which image you want to test on your target device. That was really handy because customer, we upload the artifact, We prepare the software distribution, so the hawkBit software distribution, and then they found a list of potential OS to be tested. They just drag and drop, the required time to download the image, install, and then reboot all the process was automatic, and they could test literally in 5-10 minutes the entire thing without any manual programming on the device. So another reason, so we start from deploying testing images on customer locations. Then customers got intrigued by this, and they asked if they could use the same thing that we were doing for deploying our OS for their own images in their customer location. And so that was like something different, because now we would go through what we have done. And so we decided, okay, why don't we do something that is a delivery system for like customers that they want to update, or first flash, or update like in time in the futures their operating system. So okay, let's consider it. And we found hawkBit. hawkBit was a chance that we discovered because another product that is open source is part of the Linux Foundation. It has been presented also at the ELC in San Diego this year by the maintainer, that is Stefano Babic from Denks. Denks software, you know Denks? Denks is like the U-boot maintainer. Who does U-boot is Denks. It's like a German company that, very historically popular. And so software update has a module that implements the DDI interface. So we had like it's written in C, so pure C. We saw that client working in Linux, and we download the image from the hawkBit community, we deploy it, and we literally in a day we try it out. And this was literally the zero, the inception of everything. So we start using it. We start using it internally. Then we start using it to deploy OS images, as I said before. Another thing that actually happened was this. What we do also a lot is Android-based operating systems. So many embedded devices, they want to have Android running as an operating system. So we are doing this since 2009. And one of the things that is a showstopper for many people is I don't have a Google, it's called a GMS, Google Mobile Service. It's a special license that you have to have in order to have access to Google Play. So if you want to distribute your APK on a very specialized embedded device, so I'm not talking about a phone, right? But your medical equipment. Your medical equipment has a fancy UI and is made using Android. So you can leverage the Android SDK. You can program your software. And then the point is, I have an update for this software. How can I distribute that new package? So USB was the most popular way of doing it. And of course, is like something that you got to do locally. So the idea was, why don't we build a delivery system that could distribute also Android APK? That was super like handy for customers to just like drag and drop. So not just OSs, images, that is like a more heavy process, just deliver APK to target devices, right? For testing or production purposes. That was like a huge thing, because suddenly people were asking, oh, how can I have the Google Play? I wanted to distribute my stuff through Google Play. Why you need to distribute your stuff through Google Play? You're not doing a commercial, or sorry, like a consumer application. You're doing like a very special thing that just serves your customers. So the solution was, let's work with hawkBit. hawkBit is agnostic, right? It doesn't really matter what you are deploying once the client on the target side accept it and process it, right? So And then, so when all of this came a little bit more clear, we need to build a sustainable model. So, okay, now we got to take care of customers in the way how they do register on the system, how we can, where do we store all the artifacts, how we deploy the entire service as a 24/7 service, right? So there was like some work to do. So this is what, and I will literally spend a few time talking about the server. I'm here to talk about the client because this is where the secret sauce for us was. hawkBit was already almost perfect, if I can say that, right? It was working really cool. But if you don't have a sustainable client, it doesn't serve anything. So it's like it's completely unusable. So, but what we have done in the server side, so we created a deployment infrastructure, creating first a Docker swarm, and then we switched to Kubernetes, of course. We did the building automation, so the way we deploy the server in a way that was like really fast in case we made like modification to the code like we did. We developed like a separate service for identity management. So how we handle user registration, tenants, and who own the tenants. So our identity management allows customer to control their customer. So we have tenants, so we have a multi-tenancy system, but in the same time, we want our customer to manage their ecosystem of customers. And so we did that announcement too. Of course, we created two different deployment, one for we call personal. So for customers that just want to have a few devices, less than 20, and another tier that was more business oriented, where we can handle more than 1,000, in the order of thousands of devices. So we did the tier definition, and of course the billing logic. So hawkBit, it comes like a one installation process. You have everything working, but if you need to put like an infrastructure that generates revenue, there is a lot of things that are lacking. Of course, rollouts from Bosch is another example of how to put an hawkBit core service around other services and make a platform that actually you can make money with, right? So this is what we have done on our side. Of course, the availability is another thing. So do you need a CDN? You don't need a CDN. CDN can work on multi-zones. Instead, you can work with S3 as the unique source of artifacts, but it's not multi-zone. So it can be like, sometimes you can have some lags if you're downloading from Japan or you're downloading from the United States or Europe. Okay, so one of the things that I want to get into is the client. So as I said before, the client was the missing point of in the picture. So there was this first implementation just for Linux in pure C. We need something more extensible and that actually implements the full DDI API. So like something that was literally ready to be used, not only with Linux, but probably other platform too. So we had some details to consider. When you do a client, there is a lot of things that you have to consider, like what happens in the field. So how many of you works on embedded space, like small devices? 1, 2. All right, so many of the things that I will be saying right now are really obvious for you, but probably for others, not. So if there is something that you don't understand, just stop me. So when you have a user standing in front of a device and you have some lag because connection timeouts or pooling time, you got to understand how to manage that properly. Or the customer will call you and say, hey, nothing is not happening in the last 30 seconds. Well, the update may happen after 30 seconds. Or what if the board has an outage during the update? So someone just unplugged the power. What happened? What is the state? What is the state the embedded device is actually into when that happens? And what happens when you put the power again? Can I handle single image updates? So single image and double updates, A and B, are really the two big choices. And and we will get into those details like in a sec. How should the device orchestrate effectively the server heartbeat states an entire update cycle? So this is really technical. So there is a state representation of a device in the heartbeat server, and those transitions has to be orchestrated. So the device is an important piece of how these states changes in the heartbeat server. How should the device handle the update of the client software itself? What if I want to update the client software that is updating the system and other packages in the system? We had like a lot of headaches in that sense. That was not really trivial. What if an update artifact is malformed? It's like, I don't know, something happened and there is no consistency. Or it's not signed. Many people now ask for, hey, I want my update to be signed so I can certify where it is coming from, right? And then we can have soft update and forced updates. When you have an update on your phone, the operating system tells you, hey, I have an update ready for you. Do you want to download it? And when you download it, it asks you, do you want to install it? All these kind of actions are on the client side, right? So this is why the client was a really big chunk that was missing in the pictures for us. So a little bit about like the client has to deal with different kind of technology that are happening when you want to update the system. The first one, the very first one is called single copy. Single copy means that you have a recovery OS, you have a regular OS and a recovery OS, and those two OSs, they switch in order for the recovery to flash a new, fresh image for the next regular boot. Of course, this is not really fault tolerant, but the use case is if you unplug the device during the update process, there is a way to control that from a bootloader perspective that didn't work. And when you reboot, you find yourself again in the recovery process. And you try in recovery all the time until the flash action is not completed correctly. The double copy is what your Android phone, because I'm an Android user, so your Android phone is implementing today. So memories, storage memories became like cheaper in the past year and a half. So now you can feature eMMC that are the SSD in your phone that is like 64 gigabytes. So with this, you can literally have two copies of the operating system. And when I say two copy, one OS is not just one partition, it can be like 7, 8 partitions. Today, Android is like almost 8 partitions. So you have two slots, they are called slots, of those schemas, and so your phone is hosting both of them, and it can switch. So when you have when you have your system updated, the current slots actually wrote the new OS on the other one, and then you reboot the image, and then the bootloader switch the pointer to the partition that will be booted. Of course, this is the most reliable because you have fallback options, right? And pretty much it's very consistent. Otherwise, you can always roll back to the original OS that was previously installed. All of this has to be considered when you do a client, right? All right, so the idea of, so we decided, we want to do some work on the client space, but we want to do that right in order then to be like an important like improvement for what we do, but also something to give back to the community. So we decided from day one that this project would have been an open source project. So we opened the code like 2 years ago. And so first of all, for visibility, our customer wanted to see that there was no magic or bad things happening, and so they could eventually build the client by themselves, and we will be using the same build that they were building from the sources. So that's pretty much transparency. But the way that we designed the client was what we spent a lot of time thinking. And this diagram shows you the main components. So this is a general guideline for implementing any hawkBit client. Then we will get into what we have done, but this design is pretty much something that you can apply to any operating system and any framework your embedded device is working. You have the hawkBit server. Let me look at the time. Of course, you have the DDI REST API. What we developed immediately was what we called the DDI core library. So the DDI core library was the library that was implementing the full API from hawkBit. Then we created an interface that actually the interface is something that you add that library at compile time to your project. So you have, like all the availability of the API as classes. But the central piece is a service that is running in the background, and it can be an Android service, a Linux service. We don't do Windows, but it may be a Windows service. And then the service is just like running like a daemon in your system, taking care of all the communication with the backend. But then you may want to write an application that hide the service, and you want to have full control of what the service is doing from your application. So you need to define what is a service consumer, right? And you need an interface that usually is carried on through an inter-process communication. Android has his own. It's his own messaging system. But in Linux, there is dbus. You're really familiar probably with dbus, right? And dbus is a perfect example of how a service can communicate and exchange messages with a service consumer. And at the end of the day, we have an application that wraps the service consumer API, and is the only way your system is controlling the client. And then, of course, everything is coming from the hawkBit server. Again, many of the systems we are working they work in kiosk mode. Kiosk mode means you boot the system, one application is loaded, and that application is where the user interacts all the time. Can be an instrument, can be like a gateway software. It doesn't really matter, but that is the only way the system, the users can interact with the system. So very siloed, really protected in terms of interaction with all the system components. So going a little bit into the detail what the client does, this is a little bit hawkBit specific. You know that the hawkBit server can tell the client to do some actions. Primarily, there are 3 types of actions, but 2 are really important. That is, do an update, so do an update, or cancel, like remove, like just like don't try to cancel like a previously action of updating. And the client replied with a feedback, and the feedback has some attributes. So all of these things that hawkBit gives you the power of controlling has to be done by the business logic into the client. So provide cancel feedback, provide update feedback, download artifacts, set the target attributes. Forget about this right now because it's like really specific, but these are great features of hawkBit. Actually, device attributes, we do magic with device attributes. We can tell, hey, this system is running this specific Wi-Fi chip. If this specific Wi-Fi chip is A, do that update. If it is B, do the other update, because the firmware of the Wi-Fi chip is different between 2 images, OS images. So what happens on the server, we said before that the client is, the target is represented with states. And the transition between these states, right, is made through an action. For example, if you have a registered device that is a state in the server, and you want to go into another state, it's called pending. so when the device is doing something, there is an action, right? And the client will reply to that particular action that has been sorted from the server with a feedback and a status. And so there is the service knows all the time where the client is in terms of what is he doing, and the client can give feedback of what is happening locally, so the server can eventually react. And of course, in sorry, let me see if there is a pointer here, right here. So with this symbol, I want to just say there is some logic that you can actually do in the client for eventually changing the status of the client on the server. So target states in the server. So these are the 5 states that, from a target perspective, that are defined in hawkBit: unknown, register, in sync, pending, and error. What really is important are the 2, in sync and pending. In sync means that whatever distribution has been created and downloaded into the device is actually running on the device. You want to have that state right after an update. Pending means that something is going on. Like I'm downloading the artifacts, I'm installing the artifacts, I'm trying to re-download the artifacts. Something happened on the connection, so I'm in progress. Error is like error. It's a very important state too, but we don't want that state so often, right? These are the feedback. So we said the server sent an action, the device has to process that action, and he has to tell back the server, hey, this is what I'm doing, with some kind of feedback and statuses. So canceled, rejected, closed, proceeding, scheduled, resumed. All these statuses tells the server where the client is at. So how this is all in the API of hawkBit, and write the logic is a job, because from all this power, you gotta design your business logic in order for your device to use all these things in the right way. I don't want to go into this, but these are the states I talked to you, right? And this is where we want to go, right? Let's say that your device registered because you first polled this hawkBit server, and then what you do is you assign a distribution, just drag and drop your distribution set to the device, then the device goes into the pending state, and then there is logic here going on, and you go or here or here. We want to be here, so everything went right. Other task right here, what is important is this. So as you know, hawkBit has configuration parameters, like where is the server? What is the type of authentication? Are you using the token gateway? Are you using the gateway token? Are you using the device token? So the level of security that hawkBit is offering can be like more or less permissive. And then by here, so we got to deal with the configuration of the server. We have to process an update. We have to cancel the update. We got to ask for pending action to the server, right? Let's say that you want to download more than one image and put that in a pipeline. You have something going on to handle, and we will see how we do it. But all the time you're asking to the server, the principle of hawkBit, the client asks to the server, what's going on for me? This is like in one sentence what is happening from the 2 entities. Hey, there is something for me? No, okay, I'm idle, right? And so this is the representation in the server. This is the representation in the client. So we have a state machine in the client too. It's a little bit simpler than the server one, but it's like it takes care of everything that is happening on the client. Basically, the client can be idle, downloading something, or applying an update, right? And of course, we can go back to these 2 states, download and idle, because we cancel, or because we download something that it's a malformed image. So we didn't materialize any distribution actually in the device. When we do that right, of course, we can apply the update, and then we complete the update and we go back into the idle state. Idle state, of course, is the same if we we change config data or we can cancel an action, but this is like technicality. But basically, 3 states for defining the client operation, and this is what is really like a core part of what we did. So because the interaction has to be asynchronous, has to be because there are a lot of things that can happen simultaneously, we decided to use an actor model uh, like design for the DDI lib. The DDI lib, remember, is the core library that the service is using to communicate with the hawkBit server. And for doing that with the extremely like asynchronous way, we used an actor-based model, and we did that actually in the implementation of the core library by using the coroutine in Kotlin. So the first revision that we did, like the 0.4, was written in pure Java. So you can use actually the library in with Linux too. You write your own Linux service, but the library is exactly the same. We did also for the 1.0, but we switched to Kotlin because coroutines was a way to describe more an actor design like this. That with Java was a little bit too verbose, using futures and stuff like that, like reactive approach is a little bit complicated. Here, so we see all the messages. So basically, we have an actor just for the actions that are happening on between the client and the server. We have, of course, a connection manager that you poll the server. The server tells you, hey, these actions are for you. And then if there are actions that are relating to an update, you gotta download the artifacts. How many? You can do like 2 or 3 or 4, and you need like threads for handling this at the same time. And then the download manager is controlling all the artifacts download. And then if the distribution, you remember that the distribution is materialized correctly, you go back and then you are ready to update on the device. So writing the stuff on the device. Service consumer. So DDI lib. Then we said there is a service that wrapped the DDI lib. And then we want to make the service completely hidden from the users, but the application running in kiosk mode is doing everything with hawkBit. So here we have the service consumer that we did like an example of service consumer is part of the repository. So we did that implementation also in for Android. But of course, can be any third-party app. So what we do here is basically we want the service to notify our app. Every time there is something going on between the service and the hawkBit server, we want to just have a notification, like your phone. Exactly the same that happens when when you receive an update from Samsung for your Android phone. And we are doing exactly this. This is the polling time. You know that you can set the polling time in hawkBit 30 seconds, a minute, 5 minutes, right? So these actors said, okay, I'm checking the pending action from the device to the server every X time, right? And of course, I launched the service at the booth. And here is just things that happens in terms of notifications. So when you subscribe, because the system, how the consumer actually interact with the service, you subscribe to certain notifications. So if you subscribe to certain notification, you receive that notification. Or if you don't want to receive any more notification, you just unsubscribe to the service. And of course, we also need to read the configuration, the server configuration. Uh, uh, Something about this slide. Other use cases really important are this. So we said before, and this is really cool about hawkBit, they support soft update versus forced update. Forced update happens without the user to be asked for. So when the download is completed, I deployed, and I reboot the device in front of the user. No user interaction at all, right? But if you want to do something that is more user controlled, so you gotta authorize download and you gotta authorize installation. And these are really important use case that you want to do, or through your like special API, so you do your own application like we did with our example application. But of course, you want to do that with the API between the service consumer and the service. So all of this is already we have already done this in the service consumer implementation API. So you will find that already in place. Okay, so this is another way of seeing the communication between the service and the service consumer. Again, here is what happens when you ask for the user for an authorization of downloading VDA or updating. Again, can I download? Yes. Can I update? Yes or no. Of course, between the service consumer and the service, you have the sync message, and so you return the current configuration and the current state, the client state, right? So we have, remember, idle, downloading, and updating. And of course, you can configure the server from the service consumer. So you have calls to set the connection parameters, and everything is a configuration for the hawkBit server. So we put a lot of effort designing this. We separate the logic between the service and the DDI API, hawkBit API implementation on the client. We developed a service and service consumer model, and the interprocess communication, depending on the framework that you're using and the operating system, can be different, but that design holds the same. We have published right now, since, I don't know, like 6 months, the 0.4. The 1.0 release candidate 3 is ready. I was waiting for the Eclipse Foundation to actually give me the thumbs up for this to be an Eclipse project. So hopefully this will happen shortly or not. Let's see, but anyway, we will be publishing the 1.0 in November. So this is pretty much already in place. Some links. So of course, we wrote the entire documentation on updatefactory.io, and the code is available on github.com/Kynetics. So I don't know how much time do we have right now. We've run out, but I finished everything, so no questions. This is this is good or bad. And thanks for your attention.